In an environment, brass and steel wires of length 1 meter each with areas of cross section 1 millimeter squared are used. The wires are connected in series and one end of the combined wire is connected to a rigid support and the other end is subjected to elongation. The stress required to produce a net elongation of 0.2 mm is given Young's modulus of steel 120 into 10 raised to 9 SI units and Young's modulus of brass 60 into 10 raised to 9 Newton per meter square. Acha, so we have two wires. Suppose this is our support. This is our brass wire. Okay, suppose this is our brass wire, and then we have got the steel wire. Let us show it in blue color. Now, good thing about these wires is that they have identical cross-sectional area and length. Okay. Yes. Now, the other end is subjected to elongation. That means there must be some force that must be pulling the wires down. They want us to determine the stress required to produce a net elongation of 0.2 millimeters. Okay, now look here. When wires are connected in series, okay, when wires are connected in series, elongations add. Okay, elongations add, but F is same. Okay, F is same, and when we have wires in parallel, okay, when we have wires in parallel, here elongation is same. Okay, for parallel wires elongation is same and forces are added to get the net force. Okay, so remember that particular result. Okay, now coming back to the question, we have to determine the stress required to produce net elongation of 0.2 millimeters. Okay, so I can say that net elongation, that is delta L, is delta L1. Let us say this is first wire plus this is second wire. Okay. Now, under validity of Hooke's law, what expression do we know? Sigma is equal to y epsilon. But what is sigma? Okay, now we want the okay, so we want to determine the stress, and because look here, the force is same, right? The force is same for both the wires, and secondly, both wires have the same area of cross section. Now, because the area of cross section and the force acting on both the wires is same, the stress value will be same. Okay, I hope you got that point. So there is no need to introduce F upon A there unnecessarily. What will be the strain here? Change in length upon original length. Okay, is it clear? So, so what is delta L now? Delta L is sigma L upon Y. Okay, delta L is sigma L upon Y, and now we can use that here. Okay, net elongation is 0.2, so 0.2 into 10 raised to negative 3. Sigma is what we want to determine, so we can take sigma common. I think we can also take the length common, and length is equal to 1. Nice. Length, okay. Yes, length is equal to 1 meter, both wires, right? So when this length is equal to 1, there is no need to write that length. So it's just sigma into 1 upon the Young's modulus of first 120 into 10 raised to 9, and for the second one it will be 60 into 10 raised to 9. So that's a pretty simple problem. Okay, a simple equation rather. We have to now find sigma. Okay, how can we find sigma? First okay, wait, let's first get rid of this. We can take that 1 upon 60 common, right? Now if we take 1 upon 60 common, we will have 1 upon 2 plus 1, so that will be 3 by 2, correct? That will be 3 by 2. So how much will sigma be? 0.2 into 10 raised to negative 3 into 10 raised to 9 into 60 into 2 upon 3. Okay, raise your hands if you have understood this. Okay, okay, fine. Now what remains is simplification. It's 20. Now this 20 and here we have got 0.2, so they effectively make 4. 4 into 2, that is 8, into 10 raised to negative 3 plus 9, so 10 raised to 6 Newton per meter square. Yes, for this MCQ, none of the options is right. Okay, correct value of the stress is 8 into 10 raised to 6 Newton per meter squared. Okay, clear? Now they have not asked, but we can actually find 3 things here. Okay, we can find the force F, okay, by multiplying stress by area, and we can also find the individual elongations now. Okay, although that is not required, we can find the individual elongations. Delta L1 will be how much? Sigma L upon Y1 and so on. Okay, we can find that. You can take it as homework and determine which wire stresses stretches more. Okay, can you tell me which wire will stretch more? Brass or steel? Well, we have to just compare the Young's moduli. Okay, the changing length will be greater for the wire having smaller Young's modulus, right? Which one has the smaller? Brass has smaller Young's modulus. So delta L2 will be greater than delta L1. Right? Delta L2 will be greater than delta L. Any doubt in this MCQ? It's a pretty simple MCQ, okay? If they want to complicate things, they might say what will be the elongation in brass. It will be greater than 0.1, right? Because the total is 0.2 and brass's elongation is greater than that on the steel, so it has to be greater than the half of the total elongation. Okay? Okay, so I will leave that part to you.